Welcome to Study Loop.
So for the part A of this problem, we have a single process that can be broken down into two smaller processes. So for the first part of the first sub-process is going to be the change of volume under constant pressure. So we will mark the point 1. This will be the starting volume. And then the volume expands and becomes twice of the initial volume. This can be somewhere here. This is 2V. And the pressure is constant here. This is the pressure, P1. We will use one color to, this is their common point and their common point, and the process would look something like this. A straight line, constant pressure, the only change is in the volume. Now, for later on, the both pressure and the volume will change, but they will change adiabatically. This means that the point that will be somewhere here. This is the volume, and this is the dropped pressure after adiabatic process. The point will be somewhere around here. Between this is point 1, this is point 2, and this is point 3. Between, we can say this is pressure 3 and volume 3, corresponding to the point 3. So in this case, we have an adiabatic process. So we will have a curve, slight curve between the points 2 and 3, like this. And the direction is in this from 2 to 3, and here the direction is from 1 to 2. And this here is the pressure volume diagram that was asked in the problem for the part A of the problem. Now for the part B of the problem, we need to find the total heat. So the total heat, change of the total heat, is the sum of heat exchange in both sub-processes. So we have one process under constant pressure and we have another adiabatic process. So the total heat exchange is the sum of the heat exchange between point 1 and 2, and then the heat exchange between the points 2 and 3. Now this 2 to 3 is an adiabatic process, meaning there is no heat exchange. So it will be only equal to 1 to 2. And in this case, this is a change happening under a constant pressure, so this will be N times Cp times delta T. And we can substitute the known values to obtain that Q total equals 2 moles times 20.78 joules per mole Kelvin times 300 degrees, 300 kelvins. When we put these values into a calculator, we obtain that the Q total is equal to 1.25 times 10 to the 4th joules. And for the part C, after the part C, we have two more parts of the problem. So for the part C, the total, we need to find the total change in internal energy of the system, in this process. But we need to observe one thing. From the definition of the internal energy change, we know that it is equal to N times Cv as the heat capacity under constant volume times delta T. Now, one process is adiabatic and so it has no heat exchange at all, and one process is isothermal. The first process from 1 to 2 is under constant pressure and it's isothermal. So the total change in internal energy will be equal to 0 because this part here, this term here, equals to 0. So delta U equals 0. This is the answer to the part C. The part D, in this case we need to find the work done, which can be derived from the first law of thermodynamics. So Q equals delta U plus W. And therefore we can say that W equals Q minus delta U. But since we already evaluated the value of Q and we know that internal energy doesn't change, it's 0, this is equal to Q. Therefore, from the previous evaluations, we know that W equals 1.25 times 10 to the 4th power joules. And finally, for the part E, so here we need to start from this is about the adiabatic part of the process. So we can say, we can immediately use the law that says the ratio of the volumes for the adiabatic process is equal to ratio of the temperatures on the specific exponent. This is 1 over gamma minus 1. This can be rearranged, and we can say that since we are asked to find this final volume, V3, the volume that corresponds to the point 3, it will be V2 T2 over T3, 1 over gamma minus 1. And we know all of the values. We know value for the second volume, or for the volume corresponding to the point 3. We know the value of the T2. We know the value of the T3, and we can simply substitute the known values. Also, notice that the gamma is 1.67. So this will be equal to V3 equals to 0.06 meters cubed times 600 over 300. This is in kelvins, but kelvins cancel out. And this is going to be 1 over 0.67 meters cubed. And the final answer is that the volume V3 equals 0.17 meters cubed. And now the whole problem is solved and completed. I hope you find this helpful, and I hope to see you in another lesson.